Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will deal with a very important but basic of operational amplifier, one very important concept that is called as virtual ground or virtual short concept. On that concept, the whole application of operational amplifier is based. So let's see what that virtual ground and virtual short in my operational amplifier circuit. The term virtual indicates that this is not mechanically or physically connected to ground, or not mechanically or physically connected to another circuit with resistance R is equal to 0. That means short circuit. Now, before learning virtual ground concept, we will remember two important characteristics of operational amplifier. This is our symbol of operational amplifier. Inverting terminal, non-inverting terminal, pin number 2, pin number 3. Now if we have the resistance placed, let's say Namakaran R1, and here a resistance, let's say R2. This is feedback resistance RF. Let us consider that this voltage V1 I have applied and here I have placed ground. So it's an inverting configuration of operational amplifier. Now in that case, two characteristics we have to learn. The first characteristics is input impedance Ri is equal to infinity. And second is your output impedance Ro is equal to 0. Internally this circuit is looking like, internally second pin is connected actually with the third pin with input resistance Ri, and this output is internally connected with one resistance, that is Ro, which is again connected with voltage source, and then it is connected further to either minus VE or ground. Here I can name this as AV multiplied by VI. That VI indicates the difference between these two voltages. So here I can say the difference is VI. Okay. Then I can say that if Ro is equal to 0, can I say that whatever VO I will be getting, that is nothing but AV into VI? Is that correct? Yes, obviously. Now if you learn this particular formula, I also know one more characteristics, that is your gain, voltage gain of operational amplifier is very high, right? So third characteristic is voltage gain is very high. I am writing very high because I am talking in terms of practical situation. I am not talking in terms of infinite, voltage gain is equal to infinite, which is not possible. If we are saying AV is very high and your VI is very low, obviously if AV should be very high, then VI has to be very low, because the value of AV is equal to VO upon VI, right? So if VI is very near to 0, tending towards 0, VI, that means V1 minus V2 is tending towards 0, can I say that the value of V1 is equal to value of V2, right? And this is nothing but the situation where I am saying that this potential and this potential having same value mathematically, conceptually, as well as practically. If we take an example, AV is equal to, suppose, for example, AV is equal to 10 lakh. To have AV is equal to 10 lakh and suppose my output voltage is 10, can I get the value of this VI in terms of microvolts, right? And when we compare the value of output voltage with your microvolts, so this difference is in terms of microvolts, I can neglect that, and that is why we have this VI is equal to 0, and that is why your value of V1 is nearly equal to V2, and this is called as virtual short. Considering the fact that input impedance is equal to infinity, that means internally it is open circuit. Internally it is open circuit. Keep this in mind that what I did mention, that virtual ground means physically not connected, but conceptually it is having same potential, and that is why we are saying it's virtually short. Okay, first we will understand virtually short, and then we will take the subset of virtual short as virtual ground. See, V1 and this V2, let us understand that the fact that this is V1 dash and this is V1, this is V2, so V1 minus V2 is equal to 0, that means V1 is equal to V2. So they has to be short circuited with each other, but they are not connected internally as a short circuited. This is because Ri is equal to open circuit, Ri is equal to infinity, and that is why I can say that it is not physically connected such that short circuit, but they have same potential, and that is why I am saying that it's a virtual short concept. Understood virtual short concept. Second thing, virtual ground concept. Now if I say that if this potential, right, if this concept is called as virtual short. Now if we say that V2 is equal to 0, then can I say that V1 is equal to 0? Now can I say that V1 is connected with the inverting input terminal of operational amplifier pin number 2, but this is having potential is equal to 0, that means it is actually connected to ground, but it is not physically connected to ground, and that is why we are saying that this is virtual ground concept when V2 is equal to 0. So this concept is called as virtual ground. Now we will conclude this complete video on the statement that if in operational amplifier two input terminals, pin number 2 voltage and pin number 3 voltage, this has to be have equal value, that means V1 equal to V2. This is called as virtual short concept. And when if voltage in the third pin, that is V2, is connected to ground through any resistance, because current is not flowing in this particular branch, then I can say that this V1 is equal to V2 is equal to 0. This is called as virtual ground concept. If V2 is not equal to 0, then it is called as virtual short concept. So virtual ground is actually subset of virtual short. In upcoming videos, we will use this concept directly for any kind of derivation, for any mathematical expression. I hope you have well understood this virtual ground and virtual short concept. If you like this video, obviously like, share and comment on this particular video, and obviously subscribe Ekeeda channel. Thank you very much.